What if there was a computer so powerful that it could solve problems no machine on Earth can solve today? Problems that would take millions of years for even the fastest supercomputers. Solved in minutes. This is not science fiction. This is quantum computing. A completely new kind of computing. Not faster in the usual way, but fundamentally different. But quantum computing is often described as mysterious, confusing, and impossible to understand. So in this video, we're going to do something different. No equations, no advanced physics, no technical jargon, just a clear, simple explanation of what quantum computing is, how it works, and why it could change the world. This is quantum computing, explained for everyone. 1. How normal computers work. Before we can understand quantum computers, we need to understand the computers we already use. Your phone, laptop, and every modern computer works using bits. A bit is the smallest unit of information, and it has only two possible states: 0, 1. Think of a light switch. Off equals 0, on equals 1. Every photo, video, website, and app is built from billions of these tiny switches. Modern computers are incredibly fast at flipping these switches. But no matter how powerful they become, they still work one step at a time. For some problems, that's enough. For others, it's not. 2. The limits of classical computers. Some problems grow exponentially harder as they get bigger. For example, simulating complex molecules, optimizing massive systems, breaking advanced encryption, modeling the behavior of nature itself. Even the world's best supercomputers struggle with these tasks. Not because they're slow, but because reality is more complex than binary logic. Nature does not operate only in a south and one south. And this is where quantum computing enters the story. 3. Enter the quantum world. At the smallest scale of reality, the quantum level, the universe behaves very differently. Particles can exist in multiple states at once. They can influence each other instantly over distance. They behave more like probabilities than solid objects. This strange world follows the rules of quantum mechanics. And quantum computers are designed to use those rules, instead of fighting them. 4. Qubits, the heart of quantum computing. Instead of bits, quantum computers use qubits. A bit is either 0 or 1. A qubit can be 0, 1, or both at the same time. This idea is called superposition. An easy way to imagine it: a classical bit is like a coin lying flat, heads or tails. A qubit is like a coin spinning in the air. While it's spinning, it's not just heads or tails. It represents both possibilities at once. This allows quantum computers to explore many solutions simultaneously. 5. Entanglement, quantum connection. Another key idea is entanglement. When qubits become entangled, their states become linked. No matter how far apart they are, change one and the other changes instantly. This allows quantum computers to process information together, coordinate calculations, behave like one powerful system. Entanglement is what gives quantum computers their extraordinary potential. 6. Why quantum computers are so powerful. When you combine superposition, entanglement, and quantum interference, something remarkable happens. Quantum computers don't just try solutions one by one. They explore many paths at the same time and amplify the correct answers, while cancelling out the wrong ones. Specific problems. This can create speedups that are impossible for classical machines. Not faster by 10 times, but by millions or trillions of times. 7. What quantum computers will be used for? Quantum computers are not for everyday tasks like browsing the internet. They are tools for very specific, very hard problems. Potential uses include designing new medicines and materials, simulating chemical reactions exactly, optimizing global supply chains, improving artificial intelligence, understanding climate systems, breaking and creating encryption. They could help us understand nature because they work the way nature works. 8. The challenges and limitations. Quantum computing is powerful, but extremely difficult. Qubits are fragile. They lose their quantum state easily. Quantum computers require near absolute zero temperatures, extreme isolation, advanced error correction. Today's quantum computers are still experimental. They are not ready to replace classical computers. But progress is happening, slowly and carefully. Quantum computing is not magic. It's not a faster laptop. It's a new way of thinking about computation itself, by using the strange rules of the universe. Quantum computers may help us solve problems we once thought were impossible. We are still at the beginning. But this technology could define the next era of science, medicine, and discovery. Quantum computing is not just about the future of computers. It's about the future of understanding reality